To all of the participants who've joined, welcome. My name is James Cowling. I'm the Sales Director at Martec, and this afternoon we're going to be presenting in conjunction with Matt Cortese and Tim O'Leary from CTC, some of the new technologies, new developments related to the vibration analysis, hardware, and monitoring equipment that CTC have. Martec are a distributor for CTC in South Africa, and very proud to be associated with a company that has globally is one of the most recognized and well-known suppliers of accelerometers, cables, and associated vibration analysis or vibration monitoring equipment. So that's enough from my side. Just a quick introduction. As I said, you're more than welcome to use the Q&A to type a question if you have, or the chat side, and we'll answer those as we go. But now I'm going to hand over to Matt to give you the background and run through the presentation from a CTC point of view. And I hope you guys find it informative. And as I said, if there's anything, can either contact Martec or CTC, and we're more than willing to assist when it comes to any of their queries or questions, or if you need sensors. So I'm going to now hand over to Matt.
Thank you, James. And thank you for everyone that has joined us today. My name is Matt Cortese. I am the head of sales management for EMEA here at CTC. So I've been with the company for about 4 years now. And my role here is being the kind of main point of contact for all of our distributors and customers all across Europe, Middle East, and Africa. The presentation today will be on building your vibration monitoring system. I'll cover all of the components that are needed, and then I'll expand on CTC and the solutions that we offer. Later in the presentation, Tim O'Leary will be joining us as well, and he will be covering the condition monitoring utilizing proximity probes. So I will first start off with an introduction of CTC, or Connection Technology Center. CTC was founded in 1994, and we actually did not manufacture any kind of vibration analysis hardware. A lot of people don't know that CTC actually began as a service company. While offering condition monitoring services, CTC slowly began offering our own products like cabling, as well as private label sensors, all the way to the point to today where we now offer condition monitoring hardware in over 130 countries all around the world, and we no longer offer any type of services. CTC solutions are proudly made in the USA at our facility in upstate New York. We're located in a city called Victor. It's actually more toward Canada, so about 5.5, 6 hour drive from New York City. But this is our facility where we do all the manufacturing, the marketing, engineering, sales. We're all based out of Victor, New York. One other thing to mention is that all of the raw materials we use to manufacture our products are sourced locally in the US. CTC is well known for our best-in-class warranties, and I'll expand more on that shortly. We are ISO 9001 certified, and we serve the industrial vibration analysis market, and design and tested to meet real-world demands of industrial environments. So to this day, CTC is a family-owned and operated company. We were founded by Todd and Laura Cook, who can be seen in the pictures there. They started the company in 1994 and are still heavily involved to this day. Additionally, the next generation of the family is beginning to kind of take over as their sons, Andrew and Daniel, as well as their daughter, Charlotte, now also work in management positions at the company. I always like to mention the fact that CTC is a family-owned and operated company when I introduce CTC to people. And the reason for that is because you truly feel the difference when working and receiving support with us. It's very different than working with a manufacturer that's owned by a large corporation. And I think anyone that has any kind of experience working with us can attest to that. And the family-owned aspect of CTC is one of the things that I enjoy most about the company. Another thing to highlight here is our unconditional lifetime warranty. I mentioned the best-in-class warranties on the previous slide, and what that was in reference to is this unconditional lifetime warranty, and it's something that we honor on all CTC labeled products. So this quite literally means that if you purchase a product from us, for example, a cable or a sensor, if at any point throughout that product's lifespan it fails, for example, if the cable gets cut, if there's a fire or something and then the sensor or cable is damaged, CTC will replace it at no charge. So the images on the slide are all products that have at one point been returned to us, and these were replaced with brand new products at no charge. We were first to market with this warranty. A lot of people thought we were kind of crazy to offer something like that. But we were confident in the quality of what we're offering, and it ended up becoming one of our main selling points, and it's still something that we honor to this day. Again, if at any point anyone has any questions, please feel free to interrupt me. I know there's a Q&A chat, so I believe James will interrupt me as well if something comes up. So let's get into the components and the steps that can be taken for creating your vibration monitoring system. The first step and the first component are the sensors. So sensors are arguably the most important component of every vibration monitoring system, as everything starts at the sensor. Sensors are mounted on rotating equipment to measure the machine's vibration levels. These sensors are capable of converting the mechanical motion of vibration into a measurable electrical signal. That electrical signal can then be used to predict and prevent potential failures in the piece of equipment. CTC offers a wide variety of sensors that I will dig deeper in a later slide. The second component of the vibration monitoring system is the mounting hardware. There are two methods of taking measurements. The first method being a permanently mounted sensor, and the second method being using this type of hardware portably. So I'll go through each option and we'll expand on kind of the benefits and drawbacks of each. The third component is the cable assemblies. So the cables and connectors are used to carry the signal from the sensor to the data collection point, whether that be a data collector, PLC, or DCS system. Cables were actually the first product that CTC ever began manufacturing ourselves. The story goes that a gentleman approached Todd Cook, our CEO, with a BNC to BNC cable. The gentleman pulled on each end of the cable and snapped the BNC connectors off. And then he looked at Todd and said, "If you could build me a cable that lasts, I'll give you a hug and a kiss." Todd said, "Thank you. I appreciate it, but I'll pass on the hug and kiss, but I will build you a cable that lasts." So kind of a silly story, but fast forward to this day, CTC is now known worldwide for having the highest quality cabling and backed by an unconditional lifetime warranty. The fourth component of a vibration monitoring system is the enclosure. Enclosures and junction boxes are mounted locally to the machine and can be used to take measurements from multiple sensors in one central location. You don't always necessarily need to utilize a junction box, as you can just run the signal directly from the sensor back to your monitoring system. However, having that option to take manual readings local to the machine can also be helpful. And then finally, we have data collection. So CTC hardware is compatible with all data collection systems, and we offer compatible connectors to all of the major data collector devices on the market, and I'll highlight that as well. So to begin, so step one.
Matt, just a comment from our side with regards to the enclosures. In a lot of cases, we have some of our customers where just getting accessibility, from a health and safety point of view, either guards or you can't enter a certain area or certain part of the plant from a zoning requirement or a health and safety requirement. So then having the sensors on the equipment and then running the cable out to a termination box allows them to effectively monitor from outside of that zone. So where we have some of our mining and our petrochemical clients where EX rating or just being able to enter a certain area is not possible. So that is one of the applications where using the junction boxes and the cables and pulling it into a safe zone where they can connect up an analyzer or either take it to SCADA or DCS, as you mentioned. We're starting to see that requirement in our market is becoming more and more prevalent as well.
Yes, thank you, James. That's a perfect example of an application that you can utilize the junction box, like you mentioned, the hazardous area where you're not able to enter that area and take a reading. So exactly, you can install that junction box outside of the area, but still be able to take the measurements from the reading. So again, I'll show some examples of the type of boxes that we have that you could potentially use for that type of application. So thank you, James. And moving forward, step one, choose your sensor. So there are a few specifications and information that you consider before selecting the sensor for your application. The frequency response and sensitivity go hand in hand, as the sensitivity of the sensor dictates the frequency range the sensor can accurately measure. For example, a general purpose sensor with a sensitivity of 100 millivolt per G will be able to accurately measure frequencies between the range of about half a hertz all the way up to 15 kilohertz. However, if you would like to use a low frequency sensor, that type of sensor will have a 500 millivolt per G sensitivity and will be able to accurately measure frequencies all the way as low as 0.1 hertz. So for low speed applications, this would be a better option than a general purpose. So and for this reason, knowing the run speed of your equipment is extremely important when choosing the correct sensor, as the frequency response should match. Dynamic range, this refers to the maximum and minimum amplitude that the accelerometer can measure. The typical dynamic range of a CTC sensor is plus or minus 80 Gs. Exit type is another consideration you should have, whether that be a top or side exit. And I'll show a few examples of that in the next slide. Exit type also kind of goes hand in hand with case size. Typically, these decisions are based on clearance limitations of the mounting location. And I'll show you the different sizes that we offer for both top and side exit sensors. And then regarding single axis or triaxial sensors, when possible, it's always best to monitor the vibration level in all three directions. Whether this is achieved using 3 single axis sensors or 1 triaxial sensor, there are many benefits and trade-offs to both. For permanent installations, the 3 separate signal axis sensors provide the highest quality data. However, this requires 3 separate sensors, 3 separate mounting spaces, as well as 3 separate cables. So alternatively, you could also utilize a triaxial sensor, which would only require 1 of each. For portable measurement, however, utilizing a triaxial sensor can be far more efficient and save the vibration analyst, time and money when taking your readings on your data collecting route. So again, exit type is something that should be considered. So top or side exit. Again, this decision is typically dependent on the clearance limitations of the installation area. However, top exit sensors are typically lighter in weight and also have a higher end frequency response. So on the right here, you will see an example of our single axis top and side exit sensor. And then at the bottom, there is an example of our top and side exit triaxial sensor. Again, here, the case size is another thing that should be considered. CTC offers case sizes ranging from standard to compact to mini. And the diagram on the right shows the dimensions of each for our top and side exit single channel accelerometers. Next, we can get into the actual construction of an accelerometer. So here are all the components that make up an IEPE, an accelerometer. So the diagram on the left shows the internal design of the sensor, as well as all of the components. One thing that I'd like to point out is that this is a shear mode design. You can see this by the PCT ceramic ring attached to the mass. As this sensor vibrates up and down, the mass applies a shear force on the ceramic ring. The ceramic ring can then convert the mechanical motion into a measurable electrical signal. Shear mode design is extremely important as the output will not be affected by any type of higher temperature. Alternatively, some manufacturers utilize a compression mode design that will have defected outputs due to thermal transients. Another thing I'd like to point out is that all CTC sensors are hermetically sealed. During the manufacturing process, the sensor is purged with helium and welded shut. The sensor then goes into a vacuum where we try to pull out any of that helium particles. This ensures a complete hermetic seal, and there are no leaks or cracks in the weld seams that could lead to ingress issues. The final thing I'd like to point out is the difference in mass size that you see there on the right of a 100 millivolt per G sensor compared to a 500 millivolt per G sensor. As you can see, the mass on the 500 millivolt per G sensor is much larger. This diagram was included to show that we offer a true low frequency accelerometer. Again, other suppliers market their sensors of being low frequency. However, all they're doing is amplifying the low end signal, which will not provide clear and accurate data, specifically for low speeds. The complete manufacturing process of these sensors at our facility is extremely automated. This is to maintain repeatability and to prevent any kind of manufacturing errors. Again, this is one of the main reasons why CTC can offer an unconditional lifetime warranty, as this would probably not be the best business model if products were continuously being returned or refunded for replacement. So that was everything that I've covered so far are dynamic sensors. They fall under the dynamic sensor category. These sensors have an output that can be used for vibration analysis purposes. A trained vibration analyst can use the frequency spectrums and time waveform data to see issues in a machine like misalignment, bearing defects, imbalance, or lubrication issues. However, not all end users have this type of knowledge or capabilities. For these cases, a 4 to 20 milliamp sensor can also be utilized. Basically, what a 4 to 20 milliamp sensor is a sensor that provides a single output ranging from 4 milliamps to 20 milliamps, and that output is proportional to the amplitude of vibration in a machine. These sensors can tell you the level of vibration. However, they cannot be used to actually analyze or diagnose the issue. The 4 to 20 milliamp signal sensor can also be used to configure alarm levels to either show warning messages or completely shut down the machine if the vibration raises to a certain level. These are a good preventative measure for monitoring equipment and preventing any unplanned downtime. Okay, so moving on here, you might be asking yourself, why not both? Again, I covered the difference between dynamic sensor compared to a 4 to 20 milliamp sensor. So you might be asking yourself, why isn't there a solution that offers you both? Why can't I utilize a 4 to 20 milliamp signal to set alarm levels, but also have the ability to diagnose the issue when something happens? So you are in luck. You can utilize one of our signal conditioners with a dynamic sensor to receive both a dynamic signal as well as a 4 to 20 milliamp output. Kind of how this works is the 4 to 20 milliamp output signal can be run from the terminal block of the conditioner back to your PLC or DCS system. And then the dynamic signal can be measured from the BNC directly on the signal conditioner panel itself. CTC also offers enclosures that can display the 4 to 20 milliamp output, as well as relays that can be used to trip the machine if the amplitude reaches a certain level. The enclosure at the top left of this slide is a potential solution that you could utilize to both display the 4 to 20 milliamp output, but also take your dynamic reading as our BNC ports directly on the enclosure itself. You can actually go one step further with these signal conditioners to actually automate your lubrication system. This can be accomplished when pairing the conditioner with one of our UEB ultrasound sensors. This ultrasound sensor combines a linear vibration output of 0.5 hertz to 23 kilohertz, and it has a resonant peak of 42 kilohertz. This allows this one sensor to give a premium output in both the vibration range as well as the ultrasonic range. This is important because ultrasound is typically utilized for monitoring lubrication issues. So this is a perfect sensor that will allow you to do both. So when paired with the SC320 signal conditioner, it allows you to get a dual 4 to 20 milliamp output from 2 separate frequency bands of one sensor. So kind of how that works is with a UEB sensor, you can configure the first 4 to 20 milliamp output to the typical vibration levels from 1 hertz to 1,000 hertz, for example. This frequency band will be used to monitor typical bearing defects. The second 4 to 20 milliamp output can then be configured to the ultrasonic range from 23 kilohertz all the way up to 42 kilohertz, and that will be to monitor the lubrication. That ultrasound sensor can also be paired with one of our Zerk adapters, which allows you to apply grease directly to your bearing, even while you're taking your reading, and you won't have to remove any component as it will be permanently installed, and you can connect your grease gun directly to that port on the Zerk adapter. So that is a general kind of overview of things you need to consider and options you have when selecting a sensor. But the next step is to choose your mounting technique. The first option is a magnetic base. These are commonly used for portable measurement. We offer these magnets in either a flat surface or 2-rail design. The flat surface magnet provides a higher frequency response. However, it is not always an option based on the machine being measured. If you are not able to find a flat surface on the machine, then you can always utilize one of our 2-rail magnets, and these are designed to take readings on curved surfaces. The next option is adhesive bases. These bases are used for permanent mounting applications. This is typically when drilling and tapping the machine is not a possibility, or if there's no flat area. We can also offer motor fin mounts that you can see in the picture to the left of this slide. These mounts are epoxied between the fins of the motor. Finally, we have the Zerk adapters. So that was just covered in the lubrication slide, but again, these can be used with a grease gun to apply grease to the bearing while taking your vibration reading. When selecting your mounting hardware, it's always important to understand the maximum frequency response you'll be able to achieve relative to the mounting technique. So as you can see at the far right, when possible, it's always best to stud mount your sensor as it will provide the maximum frequency response. However, I know this is not always possible. So the chart is a kind of a good thing to keep in mind when making your decision as you go from right to left. It shows all the different types of methods, and then it shows the maximum frequency response you'll be able to achieve based on that method. So that concludes mounting hardware. So I will now move into cabling and things you need to consider and the options you have when choosing cabling. So most of CTC's cabling options either come in 2 types of material, either FEP, which are primarily used for permanent applications, But then we also have polyurethane, which are typically used for portable applications. Additionally, we offer armor jacketed cabling to provide additional protection to cables installed when sensors are installed in harsh environments. I often get asked when an integral cable should be used opposed to a separate cable connector assembly. You can see the difference in each at the top left. The top shows an integral molded, the bottom shows an integral armored, and then the middle shows separate cable connector options. So I always say that integral cables really should only be used for submersible applications. For all other applications, a separate cable connector assembly should be utilized. And this is because if by chance the sensor or cable gets damaged while installed in the field, it's far more easier to replace each component separately opposed to replacing the entire system when an integral cable is used. So a few other things to take into consideration when selecting the cable would be the temperature limitations, chemical compatibility, any type of chemical the cable will be exposed to, and then of course the environmental factors. One kind of easy tool and convenient tool that CTC offers is the Cable Wizard. I have to give a big shout out to Charlotte Cook, as she has done a lot of work in upgrading CTC's website and making it easy and giving not only the sales team tools, but also the end user tools to finding the products that they need for their systems. So one of those tools that I like to highlight is the Cable Wizard. Kind of what that is something you can use to find the exact part number for your application. So when you open the wizard, the first thing it'll ask you is your application portable monitoring or permanent measurement? For this example, I've chosen to build a portable measurement
Matt?
cable. Yes.
Sorry to interrupt. Before you carry on with the custom cable wizard, I think there's a question that's come through related to the last slide when you were looking at the frequency response. And the question is, why do you need to consider the frequency response?
Let me just pull up that chart again. So frequency response is very important in terms of the defect that you're looking to monitor. If you have a very small kind of range that you're able to monitor, for example, if you were to use a probe tip, the maximum frequency response you'll be able to monitor is going to be only 500 hertz. So if you're looking to find a type of defect that's present in the bearing, it's very likely that that defect is going to show up in a frequency higher than 500 hertz. So for that reason, probably utilizing a probe tip would not be the best option. I use the example of lubrication, as that is something monitored of 23 kilohertz or more.
Another great way to think about it is many bearing faults or common machine faults will begin at a very high frequency, and then as they get worse and begin to degrade further, the fault frequency, as they call it in vibration analysis, will actually decrease until eventually, it's visible by the human eye and you can see the machine shaking itself. We all know at that point, there's not much we can do. So the higher the frequency response of the accelerometer you're using, the more time and the earlier warning you will get of common faults occurring in your machine. So you might see a machine fault that you still might have 6 months of running your bearing before you actually have to correct it. But now you have extra time to plan your shutdown, plan your maintenance, instead of reacting to faults as they occur in real time. And then there's also some machine faults, like faults in like a gear, like if there's a crack in a gear tooth, oftentimes faults of that nature will only be visible at above a certain frequency level. So if you have a lot of mass between your sensor and your machine housing, many times you can miss out on these vibration signatures that can actually provide you very, very valuable information if acted upon.
Okay, thanks, guys. Hopefully that answered the question.
Yeah. Thank you as well. I will jump back now to the cable wizard. So again, for this example, we are building a portable measurement cable. So if you were to select portable, the configurator will automatically show you all of the cables that fall under the portable category. So for this example, I've selected the CB104, which is one of our coiled cable options. After selecting the CB104, you will then be asked to answer the coiled cable length, as well as the connector you'd like to use. These kind of set lengths for the cable are only applicable to coiled cables. If this were a straight cable, you would be able to configure the exact length that you need with either feet or meters. This configure is also convenient because all of the connectors that are shown here will be compatible with the cable that you choose. You won't have to worry about configuring a cable that cannot be built or if it doesn't make sense. So it makes it very easy and to use to ensure that the cable you're building is possible. So after selecting the cable length, and then selecting each connector you'd like on each side of the cable. For this example, I chose a 2-socket military style connector that comes with a custom molded strain relief, as this is a very common connector used specifically for portable measurement. The second connector I chose was the BNC plug connector. So after all of that is selected, the system will automatically generate the exact part number for that cable. So again, it makes it very, very easy. So then you, the end user, could then use this part number to send an inquiry to Martec to request a quote, and they'll very easily be able to provide you with pricing in a timely manner. So that concludes cabling, and I will now move on to enclosures. CTC offers a variety of low-cost, standard, and as well as premium junction box options with both single-axis, dual output, as well as triaxial output capabilities. These boxes come compatible with channels ranging from 1 sensor all the way up to about 48 sensors. Material options include fiberglass or stainless steel, and this selection will be dependent on the environment the box will be installed in. The boxes also come in either a flat top version as well as a slope top version that you can see in the top left. The slope top versions are very commonly used in the mining industry. One junction box that I would like to highlight is our iBox series. This can be seen in the top right 2 pictures of the slide. This junction box has a front panel that will conceal all of the terminal blocks and cables. However, it can also drop down for ease of cable installment. This is one of our more efficient solutions because it will only require you to connect your data collector to either the BNC or 2-pin mill connector once. And once you make that connection, you can take your reading from each sensor. And all you have to do is switch the channel knob in the top right of the panel. Also included on this panel is an IEPE bias indicator located in the top left. This has 4 LED indicators that will either flash red, indicating an open or short circuit. It can then flash yellow for wait. And this means that your sensor is settling and not ready to take a reading. And then it'll also flash green, indicating that you are ready to take your reading. So this is one of our premium options, but again, CTC has a wide variety of solutions for all applications or requirements. So I welcome you to visit our website, scroll over the products tab, then it'll list out all of everything that you've seen today, as there are many, many more options that we have. The fifth and final step for building your vibration and monitoring system will be choosing your data collection method. CTC offers connectors compatible with all major data collectors on the market. The table on the left is a screenshot from our website. If you visit our website, all you have to do is select the brand of data collector you have. And then once you select it, you will see all of the connectors we offer that are compatible with those devices. For this example, if you would select Emerson, these would be all of the connectors that we have that are compatible with those devices. However, this is only a small handful, as there's many, many more compatible connectors. So that was the complete guide of building your vibration monitoring system utilizing sensors. If there are no more questions at this time, I can pass it over to Tim O'Leary, who will be explaining condition monitoring using proximity probes.
Hello, everybody. Matt did a great job covering our accelerometer line and the related hardware associated with that. So now, very quickly, I'm going to talk to you guys about our proximity probes. So while accelerometers are great for, hundreds and hundreds of different kinds of applications, and they're a very general purpose product, proximity probes have a little bit of a more narrowed focus for the applications that they can provide data for. So first off, the reason that general purpose accelerometers do such a great job covering such a wide array of machinery is because the most commonly used bearing in most machinery are rolling element bearings. So in roller element bearings, the inner race is connected to the outer race by rolling elements, and that itself is attached to the shaft. So any kind of mechanical vibration that's occurring in the machine has a very clear path out to the machine housing where we typically mount our accelerometers. This gives those accelerometers a very easy way to accurately measure the vibration occurring in the machine. But as we all know, not every machine, every type of machinery uses roller element bearings. So the second most common type of bearing is called a journal bearing, a sleeve bearing, or a fluid film bearing. So instead of utilizing rolling elements between the shaft and the machine housing, with these type of bearings, they use a pressurized regime of oil to suspend the shaft. This greatly reduces the friction. So these are typically found in very high speed, high horsepower type machinery. They're very commonly seen in large fans or large turbines, gas turbines, steam turbines, things of that nature. So while this oil does a great job dampening out some of that friction and preventing the vibration of the shaft from affecting the rest of the machine train, it also makes it very difficult to monitor the vibration of that shaft with traditional accelerometers. So that leaves us with the question, how can we still get accurate data on a shaft's position and vibration to perform predictive maintenance and condition monitoring without directly contacting the shaft itself? And the answer is proximity probe systems. So proximity probe systems use an electromagnetic field to generate something called eddy currents. The proximity probe systems use a very sensitive impedance reading that they can linearize and transfer into an absolute measure of displacement from the probe tip to the material that it's monitoring, most commonly a shaft. So basically, as this target material gets closer to the probe tip or farther away, it very slightly affects the impedance in the circuit created by the proximity probe. And then the driver of the proximity probe, which we'll see in the next slide, can take that change in impedance and linearize it into an extremely accurate displacement measurement. So a full proximity probe system will consist of a probe driver. So this is where you'll be providing power, and this will also be powering the rest of the probe circuit, an extension cable, and a proximity probe itself, as you can see over here on the left-hand side. There are specific lengths for proximity probe systems, the most common being 5 meters, 9 meters, or 1 meter in total length. And that's just because that impedance curve, that impedance reading that I was talking about earlier is so sensitive. We like to know all of the electrical characteristics of the extension cable and probe so we can just focus on the change in displacement. So whenever you're getting a proximity probe system, it's best practice to get a separate probe and extension cable. This makes it easy to switch out components if they get damaged. It also makes them easier to stock. And then we offer 4 different types of proximity probes. They're delineated by the diameter of the probe tip, and the diameter of the probe tip directly correlates with the measurement range of each sensor. So this 5 millimeter and 8 millimeter probe tip will have a measurement range of about 2 millimeters. This 11 millimeter probe tip will have a measurement range of 4 millimeters. And this 25 millimeter probe tip, which is really only used in special applications for very large turbines, will have a measurement range of all the way up to 13 millimeters. So the 2 most common applications for proximity probes are the radial and axial monitoring of machines utilizing journal bearings. So over here on the left, you can see 2 probes that are facing the collar of a shaft. And this is a great way to measure thermal expansion, as well as any kind of thrust measurements that may be happening on the shaft. Many times they will use 2 probes for redundancy's sake. And oftentimes these probes will be used to shut down the machine if it comes out of position, because if this shaft gets in contact with the machine housing, can often lead to catastrophic failures. On the right-hand side, we see 2 probes mounted 90 degrees apart from one another. This is what's called a radial mounting application. And with this application, you can get the overall peak-to-peak vibration of the shaft being monitored here for condition monitoring purposes. And if, oh, sorry about that. Oh, what's going on? Sorry about that. Got a bit of a fat finger. But as you can see, that radial picture on the side right there, if you have the right kind of DAC system, for instance, like a Bentley Nevada 3500 rack system or something like that, you can take that data and actually perform orbital analysis where you can track both the vibration and position of the shaft's center line in that orbit, which much similar to a vibration analysis with normal accelerometers. You can diagnose a whole field of different issues by examining the orbit of that shaft. So what differentiates CTC from much of the industry that manufactures these probes is we only have a 10 business day lead time on all of our proximity probe systems, regardless of quantity. And they are directly compatible with all of the major manufacturers of rack systems, machine protection systems, and online software. So all of our proximity probes are fully API 670. They comply with API 670 standards, which is the industry standard for governing all proximity probes used for predictive maintenance applications.
So I believe that concludes both the CTC sensor and proximity probe portion of the presentation. Are there any current questions that either Tim, myself, or James can answer?
There's nothing in the Q and answer box. There was just the one question that we had on that side, so there's nothing from that side. Participants, you're more than welcome to ask questions. A couple of things from a Martec and CTC side. We do get a lot of questions about, what is it that you need? And, CTC produce nearly over 2,000 different products when it comes to accelerometers and cables and things. But each one of those is, individually, uniquely marked, or it's got a part number. So when you are asking for a replacement sensor, or you're looking to replace a sensor, you need to basically be able to give us either, if it is a CTC sensor, we need to know what that part number is, or you basically can go onto the CTC website and have a look at the different data sheets on the different types of sensors. So that's important. And then also, also looking at the sensitivity of the sensors that you require, or for example, if you aren't using CTC sensors and you're using competitive sensors, you just need to let us know what those specifications are, and we can supply a direct equivalent from a CTC point of view. So, you can contact either Martec or CTC with regards to any inquiries or any questions or that you have related to any of the sensors or the cables or any of the boxes. So that's just something to think about. Or just explain to us what your application is. Give us a little bit of an idea as to what it is. As Matt and Tim explained, primarily whether it's side entry or top entry, and then your cabling requirements. But those are all relatively simple for us to solve. So as I said, if you've got any questions or anything, please get in contact with us from that point of view. And then I'm just looking at questions, not seeing anything else. So if there's no further questions, Matt, Tim, from your side, is there anything that you'd like to add?
No, James, I want to thank you for setting this up. And again, thank you everyone for joining us today. It was a pleasure presenting to you. And again, if there's any questions, please do not hesitate to reach out to Martec, as they've been a longtime customer and partner of CTC, and we'll be happy to support you.
Okay, then from
James, if I may, seeing as I've interrupted this webinar before, and again, apology for that. I don't know how my mute button got unmuted, but from my side also, Matt and team, thank you very much. I mean, it helps going through the stuff in this level of detail, and understanding it better, and really, it's nice for us to see the expertise that you bring to the table, and we really appreciate the relationship we have with CTC. So thank you for your support.
Thank you. Thank you.
We're always happy to support. So yeah, feel free to reach out anytime.
Thanks, guys.
Okay. Thanks, everyone. And thank you for attending, and please drive safely, watch the roads. And again, thank you very much. Appreciate it.